Welcome to the Learn English Podcast Daily. My name is Claire.
My name is James. By listening to this, you may learn English in a very simple way.
Today, we are going to talk about a very interesting topic. Please don't forget to subscribe our channel and hit the bell icon. Okay, let's deep into the topic.
Okay, so if I were to ask you, what's the single most important technology right now? But also, maybe the most poorly defined one driving business.
Yeah.
I mean, it's got to be artificial intelligence, right?
Absolutely. AI, everyone knows it's like everywhere.
Right. Your Netflix queue, customer service bots, you name it.
Exactly. But the actual definition, the mechanics behind it.
And the challenge of actually using it effectively, it all gets pretty murky, doesn't it?
It really does. It's the ultimate buzzword, maybe, but it defies an easy explanation.
Mm-hmm.
So look, our goal today isn't just to say AI is in Spotify. I think you probably get that already.
Yeah, we know that, Britt.
Right. The mission here, based on the stuff we've looked at, is to cut through all that noise and really pin down what is modern AI? How does its engine actually work? And maybe most importantly, why are so many companies finding it so hard to go from like a cool experiment
Right, a pilot project.
to something that delivers real sustainable value day in, day out?
Okay, let's start crisp then. Forget the sci-fi movies for a second.
Good idea.
At its absolute core, AI is, well, it's a branch of computer science, right? Focused on building systems, software, machines that can do things that normally need human intelligence.
Like learning or understanding language, making decisions, that kind of thing.
We often point to that SAP definition, don't we?
We do. It's a good one. It really emphasizes that AI systems can learn, reason, and act.
And that learning part, that's the fundamental shift from, old school programming.
Absolutely. It's not just following instructions. It's adapting based on data.
Okay, but straight away, we need to tackle the big confusion point. The AI we actually have today versus the AI people worry about in, movies.
Yeah, the killer robots versus the spam filter.
Exactly. So the AI powering almost everything now is what we call narrow AI or weak AI.
Right. It's incredibly good, often superhuman, but only at one specific task.
Like recommending a song or driving a car in certain conditions or reading an X-ray.
Precisely. That hyper-specialization is key. Your traffic prediction app isn't suddenly going to develop consciousness.
That's reassuring. So artificial general intelligence, or AGI, that's the sci-fi dream.
Or nightmare, depending on your view. But yes, AGI, a system with human-level cognitive abilities across the board, is still purely theoretical.
So for anyone listening who's actually building something or making a business decision now,
you are dealing with narrow AI, period. That's the operational reality.
Okay, that clarifies the now. But AI didn't just spring up last year with ChatGPT.
Yeah.
How did we get here? What's the sort of potted history?
Well, the dream is ancient, obviously, but the formal field, that really kicks off in 1956.
Dartmouth's conference.
That's the one, where the actual term artificial intelligence was coined. But maybe the more important history lesson isn't the date, it's the cycle.
The hype cycle.
Exactly. The boom and bust. You had Alan Turing proposing his famous Turing test back in 1950. Can a machine fool a human into thinking it's human?
Which sparked massive optimism in the 60s, right? Lots of bold predictions.
Huge optimism, followed pretty quickly by disappointment. The first AI winter.
Why? What went wrong?
Basically, the tech wasn't ready. Systems were too rigid, you needed way more data than they had, and computers just weren't powerful enough. The reality lagged way behind the ambition.
A familiar story in tech.
And that cycle repeated. We saw some progress, like expert systems in the 80s systems that mimic human experts in narrow field. They had some commercial success.
And then the big symbolic moment, IBM's Deep Blue beating Garry Kasparov at chess in 97.
Right, proving machines could master complex logic and strategy. But still, that was a very defined, rule-based game.
So what changed? What triggered the current AI explosion?
Two massive things, really, converging in the 2010s. First, big data. Suddenly we had unimaginable amounts of digital information being generated.
The fuel for the engine.
Exactly. And second, the rise of deep learning techniques, coupled with much more powerful computing, especially GPUs.
And that combination shifted AI how?
It shifted AI from solving neat logical problems like chess to tackling messy real-world pattern recognition problems, understanding images, understanding language.
Which paved the way for the whole generative AI boom we're living through now since about 2022, ChatGPT, DLE, all that stuff.
That's right. That leap was enabled by deep learning running on big data. So if you really want to grasp modern AI, you have to understand machine learning, ML. It's the engine room.
Okay, let's go under the hood then. Machine learning, it's a subset of AI, right?
Correct. It's the dominant subset today.
Yeah.
And the core idea is that the machine learns from data rather than being explicitly programmed with rules for every single scenario.
So back to the classic example, teaching an AI to recognize pictures of cats. How does ML do that?
It's actually quite elegant, conceptually. Think of it in 3 main steps. Step 1, data input.
Feeding it pictures.
Millions of them. And crucially, they need to be labeled. This picture is a cat. This one is not a cat. This one is. You get the idea. The quality and the labeling of this training data are absolutely critical. Garbage in, garbage out.
Makes sense. Step 2.
Pattern recognition. The ML algorithm essentially processes all that labeled data and starts figuring out the statistical correlations. What patterns of pixels, shapes, textures tend to show up in the cat pictures, but not cat picture.
Like pointy ears, whiskers, fur texture.
Exactly. It's identifying those predictive features itself without a human telling it, look for ears. It just learns the associations from the data.
Okay. And step 3, the output.
Step 3 is model creation. Based on all those patterns it learned, the system generates think of it as a compact mathematical file. That's the model.
The intelligence part.
That's the distilled knowledge, yeah. Now, you can show this trained model a new picture it's never seen before, one without a label. The model analyzes it based on the patterns it learned and makes a prediction. Okay, based on my training, there's a 99% probability this is a cat.
Got it. Data in, patterns found, model out.
That's the essence of ML.
But you mentioned deep learning earlier. That's what powers the really cutting edge stuff. How is that different from basic machine learning? Is it just more?
It's more, and it's structured differently. Deep learning is a type of machine learning, but it uses something called artificial neural networks, ANNs.
Inspired by the human brain, kind of?
Loosely inspired, yes. The key is that these networks have multiple layers, sometimes hundreds deep, hence deep learning.
Okay, so what do these layers do?
Imagine data passing through the network. The first layer might just detect very simple features like edges or corners in an image.
Okay, basic shapes.
Right. But the output of that layer feeds into the next layer, which might learn to combine those edges into slightly more complex shapes, like circles or squares.
Ah, I see. Building blocks.
Exactly. Layer by layer, the network learns increasingly abstract and complex representations of the data. So way down the line, a layer might finally be able to recognize a cat's eye or a car wheel by combining the simpler features learned in the earlier layers.
So it's hierarchical learning.
Precisely. This multi-layered hierarchical approach allows deep learning models to tackle incredibly complex patterns in massive data sets, like understanding nuanced language or identifying subtle signs of disease in medical scans with a power that simpler ML techniques just can't match.
And these tools, ML and deep learning, they aren't just one monolithic thing. They branch out into different specialisms.
Yeah, absolutely. You hear about natural language processing, NLP. That's AI focused on understanding and generating human language. Hugely important for chatbots, translation, and all the generative AI stuff.
Okay.
Then there's computer vision, which is about enabling machines to see and interpret images and videos. Think self-driving cars, facial recognition, quality control in factories.
And robotics often gets lumped into.
Right, though it's more about the physical embodiment. AI provides the brain for the robot's actions and decisions. So NLP, computer vision, robotics, they're all part of the broader AI family, often powered by ML and deep learning.
Right. Let's shift gears then to the impact. We all see the everyday stuff. Spotify suggesting songs, Siri or Alexa answering questions, Google Maps predicting traffic.
The Waze rerouting, the spam filters.
Yeah.
Yeah, it's woven into daily life.
But where is this narrow AI really making a transformational difference in the big, complex, high-stakes industries?
Well, healthcare is probably one of the most compelling areas right now.
How so?
AI isn't replacing doctors, let's be clear, but it's becoming an incredibly powerful assistant. Think about analyzing medical images, MRIs, CT scans, X-rays. AI models can often detect subtle signs of diseases like cancer, sometimes earlier or faster than the human eye.
So augmenting the radiologist's ability.
Exactly. And it's also speeding up drug discovery, analyzing vast data sets of molecular structures to predict which compounds might be effective treatments. That used to take years. AI can dramatically shorten the process.
Wow. Okay, what about, say, the financial sector?
Huge impact there, too. Real-time fraud detection is a big one. Sifting through billions of transactions per second to spot anomalies that indicate fraud, something humans just can't do at that scale or speed. Also, assessing credit risk, algorithmic trading, lots of applications.
And in manufacturing, I hear about predictive maintenance.
Yes, that's a major one. Factories put sensors on their critical machinery. The AI analyzes the data from those sensors, vibration, temperature, noise, and it doesn't just wait for a machine to break down. It predicts when a failure is likely to happen, maybe hours or days in advance.
So they can fix it before it breaks.
Exactly. Preventing costly downtime, improving safety. It's a huge efficiency gain.
That makes sense. I also find that really extreme examples fascinating, like space exploration.
Oh yeah, NASA uses AI extensively, not just for crunching astronomical data, which is obvious, but for automating complex spacecraft operations.
Like piloting rovers on Mars.
Absolutely. With the communication delay between Earth and Mars, a human can't joystick a rover in real time. The rover needs onboard AI to navigate obstacles, make decisions, basically drive itself autonomously using computer vision and pathfinding algorithms.
Incredible. So when you look at all this, the efficiency gains, the ability to find insights and data, automating complex tasks, the potential seems enormous.
The promise is definitely huge, but, and this is the crucial but, it brings us squarely to the other side of the coin. AI is powerful, yes, but it's also a double-edged sword. It introduces significant, complex risks.
And managing those risks is paramount. We see sources like Gartner hammering this home. These aren't just theoretical worries, they're real operational liabilities if you don't handle them.
Top of the list has to be bias and fairness. This is a massive challenge.
How does that work in practice?
Well, remember, AI learns from data. If the historical data you train your model on reflects existing societal biases, guess what?
The AI learns those biases.
Learns them, and often amplifies them. So if you train a loan application AI on past data where, say, certain demographic groups were unfairly denied loans, the AI might just automate and scale up that discrimination.
Creating biased outcomes without any malicious intent, just based on the data it saw.
Exactly. And it can be incredibly hard to detect and fix. Then there's the accountability issue.
The black box problem.
Kind of.
Right.
Especially with complex deep learning models with millions or billions of parameters working internally. If the AI makes a bad decision or causes an accident.
Like in a self-driving car scenario.
Right. Understanding why it made that specific decision, tracing the logic back through all those layers, can be extremely difficult. So who's responsible? How do you fix it if you don't fully understand why it failed?
And that ties into things like job displacement fears, privacy concerns with surveillance tech. The risks are real.
They are. And managing these risks, dealing with the complexity. That's why the biggest hurdle for most organizations today isn't building a cool AI model in a lab, it's actually operationalizing AI.
Getting it out of the lab and into the real world reliably and safely.
Precisely. The stats are pretty stark, you know. Sources suggest over 80% of businesses are experimenting with AI, running pilots.
Which sounds great.
But only a tiny fraction, maybe less than 20% in some studies, have successfully deployed multiple AI systems widely across their operations and are getting consistent value. There's this huge gap.
The chasm between experiment and production value. So How do companies bridge that gap? What does it take beyond just having smart data scientists?
It really comes down to three critical pillars, and interestingly, they're mostly non-technical. Pillar one, strategy,
Meaning,
meaning you don't do AI for AI's sake. It sounds obvious, but it's a common mistake. The AI initiative must be tightly linked to a specific measurable business goal.
so not we need an AI strategy, but more like,
More like we will use AI-driven demand forecasting to reduce our inventory spoilage by 10% this year. Or we'll use an AI chatbot to improve customer first contact resolution rates by 15%. It needs a clear objective and metric.
okay, strategy first. Pillar two.
Pillar two is data. We said data is the fuel, right? Well, getting that fuel right is incredibly hard in practice.
The data quality issues.
Absolutely. You need clean, reliable, well-labeled data. But even more strategically, organizations have to break down their internal data silo.
Where different departments have their own data locked away.
Exactly. If your sales data, marketing data, inventory data, and supply chain data all live in separate, incompatible systems, your AI can't get the holistic view it needs to make smart predictions. This takes serious effort around data governance, managing quality, security, privacy, access, ethics. It's a huge organizational lift.
Right, not just a tech problem. And pillar three.
Pillar three is the people side, talent and culture.
How so?
You can have the world's best AI model and perfect data, but if the people who need to use it don't trust it, don't understand it, or feel threatened by it, the whole project will fail.
So you need buy-in.
You need buy-in, but you also need the right structure. Success requires cross-functional teams, not just data scientists in a corner, but data scientists working alongside the business experts, the people who actually run the warehouse or talk to customers or read the medical scans.
They provide the context and validate the AI's outputs.
Precisely. And this demands a real commitment from leadership to upskilling and reskilling the workforce, teaching people how to work with AI tools, how to interpret their outputs, how to use them to do their jobs better. It's about augmentation, not just automation.
Okay, strategy, data, talent, and culture. Let's make that concrete. Back to our retailer, using AI for demand forecasting. They've trained a model, they've got good data. What happens next to actually operationalize it?
Okay, so the model exists. Next is deployment and integration. This usually means wrapping the model in something like an API and interface so other systems can talk to it.
Connecting it to the inventory management system, for example.
Exactly. So the inventory system can send current sales data to the model. The model runs its prediction and sends back the forecast, which then might trigger automatic reordering or stock adjustments. It needs to be integrated seamlessly into the existing workflow.
But it's not deploy and forget, is it?
Absolutely not. That's maybe the biggest misconception. The moment it's deployed, the real work of monitoring and maintenance begins. This is continuous.
And this is where that term AI ops comes in.
Right. AI ops isn't just jargon. It's the discipline of managing AI systems in production. The core problem it tackles is model drift.
Meaning the model gets worse over time.
Yeah, its predictions become less accurate. Why? Because the real world changes. New competitors emerge. Consumer tastes shift. There's a recession, a pandemic, anything that changes the underlying patterns in the data the model was trained on.
So the model's assumptions become outdated.
Exactly. A robust AI ops framework constantly monitors the model's performance against real-world outcomes. When it detects significant drift, it needs to trigger alerts, potentially automatic retraining with fresh data, testing, and redeployment of the updated model. It's a continuous life cycle.
So for our retailer, if a heat wave suddenly causes a massive spike in demand for ice cream that the model didn't predict,
The AI ops system should flag that inaccuracy, ideally trigger a retraining process incorporating the new sales data, and push out an updated model that now understands the heat wave effect.
and this loop needs ethical oversight too, right? Back to the bias issue.
Critically important.
Yeah.
Ethical governance can't be an afterthought. It has to be designed into the AI ops loop.
Oh.
By continuously auditing the model's outputs for fairness, not just accuracy, is our demand forecasting model, for instance, systematically underpredicting demand in lower income neighborhoods because historical data showed lower sales there?
Which could lead to understocking those areas.
perpetuating inequality. The AI ops process needs checks for this kind of bias, flagging it and potentially adjusting the model or the process to ensure fairness. Ethics has to be part of the ongoing maintenance, not just a checkbox exercise at the start.
That really reframes it. Success with AI isn't just about the clever algorithm, it's much more about building these robust, ethical, continuous operational processes around it.
That's exactly the takeaway. AI is becoming a foundational technology like electricity or the internet. Its real future isn't some sci-fi singularity. It's about finding the optimal synergy between human expertise, judgment, and creativity, and the computational power and pattern find abilities of AI.
So, looking just ahead, what should people be watching out for in the near term? What are the next steps in AI's evolution?
Well, we'll definitely see generative AI continue to mature, moving beyond just novelty chatbots and image generators into more deeply integrated tools within business software and workflows, more practical applications. Keep an eye on the rise of multimodal AI. These are systems that can understand and process information from multiple types of data simultaneously: text, images, audio, video. Think of an AI that can watch a video, listen to the audio, read captions, and understand the context holistically. That opens up many new possibilities.
A richer understanding of the world.
Exactly. And finally, expect significantly more focus globally on regulation and governance. As these systems become more powerful and widespread, governments and international bodies will increasingly step in to create frameworks around their development and deployment, addressing things like safety, bias, and accountability.
Makes sense. So, maybe a final thought for our listeners to chew on.
I think the most provocative thought is this: the real competitive advantage in the coming years won't necessarily go to the companies that just buy the fanciest AI models off the shelf.
Because everyone will have access to similar tech eventually.
Right. The winners will be the organizations that master the challenging, often unglamorous, but absolutely essential work of building that ethical AI ops capability. The ones who successfully integrate continuous human oversight, ethical auditing, and adaptive maintenance into the very fabric of how they operate their AI systems, that human AI operational partnership. That's the secret weapon.
Thank you for listening. Don't forget to subscribe our channel. Let's meet soon with a new interesting topic. Have a nice day.